Okay, in this lecture, I would like to talk about uncertainty in geovisualization. Why do we need to address uncertainty? And what's the definition of uncertainty, of course, and also how should we address uncertainty within geovisualizations? Firstly, why do we care about uncertainty? Why do we care about uncertainty? First, the reason is awareness. You should know that there is always a gap between geographic data sets and the reality. Okay, there is always this gap. You cannot avoid that. A geographic data set cannot perfectly address the real world, the reality. There is always errors, uncertainty, right? And as as a GIS user or a user of geovisualization, he or she may not have enough knowledge or the background to realize that there is this gap. But on the other hand, as a GIS major student or as a GIS researcher, um, we are responsible to address uncertainty in our maps, in our geovisualizations. So people will be aware that there is this difference between reality and this geovisualization, or between reality and geographic data sets, providing information enabling the understanding of this gap between reality and representation, and it is critical. And also, uncertainty is pretty important in decision making. A lot of GIS users, or more specifically, geovisualization users, why do we use your geovisualizations? They want to retrieve information and then make decisions. And it is also critical for them to know that there is uncertainty, and the uncertainty is usually considered as negative. It's natural because if there is uncertainty, there will be a reduction in confidence on the data you are looking at, and there will be anxiety because you are not sure about what you're looking at, right? But but it's our responsibility, the makers of geovisualizations, to present uncertainty in a positive way. The presentation of uncertainty can have a positive influence on problem solving, right? Just like the two fish in this figure on the right, you can say this bottle is half empty, right? It's kind of negative, it's a bad thing, but you can also say that this bottle or this cup is half what? Half full with water, right? Obviously, the second method to address the situation of this cup, of this bottle, is better for people. Although these two methods, they are stating the same thing, right? Half empty, half full. But this is about wording. Okay, so uncertainty is important for decision making. Although it sounds negative, but we can use a positive way to address it, to show people that there is uncertainty. And also, uncertainty situations often result in a bias toward initial potential solutions. For example, undervaluing negative evidence, overvaluing positive outcomes, because people would like to say what they want to say, right? But uncertainty is something you should not dodge. You should face it directly. And in decision-making processes, experts use probabilities, equations, and statistics to address uncertainty. But on the other hand, naive decision makers or amateurs, they tend to rely on experience and stereotypes. I'm not saying that experience and stereotypes are not good, but if possible, we should rely on science instead of our experience, right? And what is the role of maps and uncertainty representation in the decision-making process? Okay, according to different studies, that visual depictions of uncertainty are useful for decision making, which means that presenting uncertainty helps policymakers to find out the risks and also possibilities for alternatives. For example, there is two maps addressing the same topic. Okay, it's an uncertainty map and the actual map on the left and uncertainty map on the right of potential biomass recovery of new tropical secondary forests in South Latin American and South America. So on the left side is biomass recovery of this area within this area. Okay, it's generally a combination of chloroplast map and gradual symbol map, right? And the chloroplast part, you can say different colors are used, different hues are used to address different extent of recovery of biomass in this area. If it is green, it means that the recovery is pretty good. If it is red, the recovery is bad. So this map is showing you the variable you care about. On the right side, it's another story. It's also a chloroplast map, right? Different hues are used to address different ranges of data, right? But within this map, although it's still green or yellow, both of these hues are also used in the first map. But here these colors, they are used to address different level of prediction error. If it is green, it means that the prediction error is low, which means that the data here is reliable. The prediction here is reliable. If it is in a bright yellow or even dark yellow, it means that, okay, the data there, the prediction there is not that good, is not that reliable. So prediction error is a representation, is used to address uncertainty here, because uncertainty is a pretty broad concept. Different indicators can be used to address uncertainty, and prediction error here is just an indicator. So what does it mean? It means that, okay, in the map on the left, this green area, very large green area, is recovering pretty good, right? And it's also reliable. This situation, the data here for biomass recovery is reliable because the prediction error is pretty low. Okay, so that's one way to address uncertainty in a geovisualization. So yeah, here, when you are looking at the map on the left, trying to make a decision, you also need the map on the right to give you the situation, to give you uncertainty within different areas. Okay, when you combine these two maps, you will probably make a more smart, more reliable, a smarter decision, right? Okay, and lay people or amateurs, they usually depend on heuristics rather than statistics when making decisions under uncertainty. Okay, examples of this method include using a rule of thumb, an educated guess, an intuitive judgment. Okay, and on the other hand, when experts are facing uncertainty in decision making, they rely on what? They rely on statistics, rely on science. But providing information about that uncertainty in an explicit visual way does help a lay or expert map reader make different decisions. Okay, although experts are more reliable, but if you can provide visual representation of uncertainty, is always helpful, no matter the user of your map, of your geovisualization is amateur or expert. And also, addressing uncertainty is a demand for good science. The definition of good science is that this science follows certain rules and guidelines and often employs scientific methods, which are considered the best objective procedure, which means there are protocols for science. If you want to call your research, a scientific research, you need to follow specific protocols, and addressing uncertainty is one of them. Okay. On the other hand, we have bad science. Bad science like this. Mad scientists are cloning dinosaurs as weapons of the future, right? This is something called bad science. And good science includes statements of accuracy. Actually, statements of accuracy is the opposite of statements of uncertainty. But when you know accuracy, you indirectly know uncertainty because they are negatively correlated, right? The higher the accuracy, the lower the usually the lower the uncertainty, right? And let's just differentiate error from uncertainty. Okay, since we're talking about the uncertainty, error is the inaccuracy that is objectively known. When you, for example, when you're trying to use a ruler to measure a short distance, let's say 10 centimeters, and after the measurement, you suddenly realize that okay, you read the ruler wrong. It should be 11 centimeters instead of 10. You realize that okay, so now you know there is an error of 1 centimeter in your reading, in your measurement, because you know that. But uncertainty is another thing. It's an inaccuracy that is not objectively known. What does it mean? It means that you're trying to use a ruler to measure a distance, right? Your reading is correct, but there is always uncertainty in the accuracy of this ruler because this ruler is not possible to be perfect. There must be some kind of uncertainty that is not known in the producing when the ruler was produced. Okay, you know that okay, this ruler is okay for daily measurement, but it's not accurate. There is always error, but you cannot tell exactly how much the error is. That is something you cannot know. This is called uncertainty, which means that when you are using this ruler, you cannot dodge the uncertainty within this ruler. But when you are using it, when you are measuring, you can avoid the error from reading the ruler, right? So that's the difference between error and uncertainty. And uncertainty covers a broader range of doubt than error alone, okay? And uncertainty representation, generally, we have two general philosophies. Report accuracy to represent the good aspects of data certainty, or report error to represent the bad aspects of data uncertainty. I would not say which one is better because depending on the specific application, depending on specific discipline you are in, they have different conventions for reporting certainty or uncertainty. For example, in remote sensing, when you're trying to publish a paper, you have a classification map for a specific area showing different land cover types. Usually, our convention is to report classification error, which means report error to represent the bad aspect of data uncertainty. But in other disciplines, I know that some of the disciplines, some journals they require you, or they tend to publish accuracy to represent the good aspects of data uncertainty. But I mean, if you are reading a specific journal or a geovisualization, you should know that there should be uncertainty addressing if possible. Okay. And preferred, we prefer accuracy. It implies reliability. It's relatively, let's just say, positive. It's positive because accuracy means your data how good is your result, instead of showing errors, which means how bad your research is. Okay. Okay, I will just stop here and see you in the next video. Thank you.